Good morning. These are your energy stories for the second week of February 2021. Last week, Ford Motor Company announced it was increasing its investments in electrification from $11.5 billion up to $22 billion and adding another $7 billion for autonomous vehicles. All of this to be allocated by 2025. CFO John Lawler said, if EVs continue to quickly gain favor, especially with commercial customers, we want to be clear we will not cede ground to anyone. They may be a little bit late on that call. He also indicated the company is eyeing potential investment in battery production either by itself or in a JV, and indicated that other EV partnerships should be announced in the near future. There's also a story last week in Electric Bus Magazine, yes, there is such a publication, indicating that of the roughly 75,000 buses on the U.S. roads, over 1,000 full-size transit buses are now electrified, with another 1,775 on order. California is, driving the bus on this one, with a goal of 12,000 zero-emission buses by 2030. There's plenty of room to grow here as costs of batteries and buses fall and customers gain familiarity. We can also look to China for its example. That country has well over 420,000 e-buses and by one estimate adds approximately 9,500 new electric buses every 5 weeks. Switching to offshore wind, the U.S. Bureau of Ocean Energy Management announced it will resume the review process for the Vineyard Wind 1 wind project, 800 megawatt project off the coast of Massachusetts. This after the initial BOEM review delays, where they were going to take a systemic view, which slowed down the whole industry, followed by Vineyard Wind temporarily withdrawing its application while it switched out its turbines from the 9.5 megawatt Vestas machines to the 13 megawatt version of GE's offshore Haliade platform. In late January, Vineyard Wind submitted a letter to the BOEM saying it was ready to proceed. In February 3rd, the BOEM said, okay, we'll start the review and move to the environmental review process. That's a pretty ambitious project, but not within the context of what Denmark's doing. That country just reached a public-private agreement for the development of an artificial island energy hub 50 miles offshore off the peninsula of Jutland, encompassing a phase 1 with 200 turbines and a combined output of about 3,000 megawatts. When fully built out, a target of 10,000 megawatts is anticipated. That hub will serve as a gathering point for all these connected wind farms and a distribution point for neighboring countries. Meanwhile, South Korea says, we don't want to be left out. We're going to play big in the offshore wind game too. And the Moon government is planning on a $43.2 billion plan to build the world's largest wind power plant by 2030, an 8.2 gigawatt complex. This is part of an effort to make South Korea carbon neutral by 2050. Heavy industry companies and utilities such as South Korea Electric Power Corp, Hanwha, and Doosan on board, and they will be footing the majority of the bill. Now let's talk tech, but we'll stay with wind for a minute. Taller hub heights result in steadier winds. The higher up you go, the better aeolian currents you get. So there's a race for altitude. Now, Spanish infrastructure firm Esteco is getting ready to complete a telescoping wind tower in China's Henan province that has 3 concentric concrete sections that slide within each other. Esteco's solution uses these heavy lift jacks that are built within the tower infrastructure that will do the self-lifting. When complete, the hub height will be at 170 meters. The company is no novice. It's built more than 1,600 towers since 2004 for several turbine manufacturers, with hub heights ranging from 80 to 120 meters. But 170 meters, that's a new ballgame. To put that in perspective, the U.S. average hub height in 2019 was about 90 meters, although the big OEMs have been moving in that direction. Last year, GE announced 3 Cypress units going into the Elfershausen project in Germany will go to hub heights of 150 and 161 meters. And finally, we can't go a week without something related to hydrogen or H2 tech, so why not something as unusual as a paste for hydrogen storage? Fraunhofer Institute researchers in Dresden, Germany have developed such a paste, which they claim can offer high energy densities and be applicable for all vehicles. Fraunhofer says the power paste, based on solid magnesium hydride, should allow hydrogen to be chemically stored at room temps and with ambient pressures and then re-released as required. The paste critical material is powdered magnesium. At 350 degrees Celsius and 5 to 6 times atmospheric pressure, it's reacted with hydrogen to form magnesium hydride. Add ester and metal salt and you get the paste, which would replace those cylindrical pressure tanks used in vehicles. There's always something new under the sun these days. Thanks for watching. We'll see you next week.